Hi, my name is Matthew Pikowski, and I'm an electrical engineer at Manhattan College, working on the senior year capstone design project with my fellow seniors from the computer engineering department. We teamed up with Institute for Career Development in designing a project called InterKinect. My team leaders are made up of individuals from both the computer and electrical engineering senior departments. On team analysts are Avinash Mohanlal and Charles Pipitone. The software designers, the main software lead was Shakid Belazaire, and his associates were Giuseppe Vaccaro, Blair Morgova, and Philip Reagan. And on our hardware side, we had Roger Scary. Those team leads were picked because of their interest in the project and the skill sets that I knew they could bring to the team, the project, and the Institute of Career Development.
Okay, yeah. You're good. You're doing good with eye contact. I love it.
The seniors at Manhattan College decided to team up with the Institute for Career Development when they visited here, speaking about the services that they do for vocational rehabilitation for adults with disabilities. Their job is to re-enter them into the workforce and help them to find a greater purpose. When we heard about that mission, we wanted to get involved 100%. We visited Dr. Les Halpert down at his office in downtown Manhattan and got to walk around his facility where they train the adults in classrooms. And one of their issues resided in the interview process. So in seeing that and seeing how they prepared the adults to re-enter the job force and help them create a better life for themselves, we saw certain flaws in that interview process. So that's where we wanted to come in, take technology that was current, the Xbox Kinect sensor for Xbox One, and the Kinect adapter for Windows, and really try and bring a certain sense of automation to that process. Just to be able to help them automate that process means they can, free up their time, work with more individuals, and increase that job number force, and get adults out there, help them create a better life for themselves. So us seniors, when we went and visited ICD, like I mentioned, we got to see their feedback processes for the disabled adults. And we got to see hands-on how their feedback is given to the participants via video playback. When the participants sit down with the associates at ICD and interview, they get that whole file to help them grow, to help them better themselves for the next set of interviews. Now, with that, we saw that maybe as not as the most effective process. We wanted to help automate that a little bit. So with the Xbox One Kinect sensor and the Kinect adapter for Windows, we had hoped to, improve the playback, the feedback of that process. In order to accomplish that, we used Microsoft Kinect Studio in conjunction with all of the packets online for development use through the Kinect for Windows adapter and the Xbox One Kinect sensor. So we were able to take those packets, which anyone can do, any developers, college students, participants, anyone can go in and code and take those packets to analyze mannerisms, eye contact, speech, voice, all of those things. And we wanted to apply that and have those be the gauges to really analyze. So in order to address this, instead of just receiving a full video playback, now the Kinect sensor and our program, InterKinect, can tell in real time the areas in which the participants are struggling, whether it be eye contact, mannerism, attentiveness, smiling, eyes closed, mouth open, things of that nature. They can really see in real time for themselves the areas in which they're lacking, as opposed to just being told by their mentors. So our intention was to provide live feedback for those participants at ICD. Now, in order to accomplish this, we faced a lot of troubles along the way. From the early stages in just ordering the Xbox One Kinect sensor with the Kinect adapter for Windows, it needed certain hardware and software requirements just to be able to run in code, whether it be a certain gigahertz processor, enough power to supply the adapter, and even the USBs were a very large issue for us. Here at Manhattan College, our server's computers only ran USB 2.0 headers, and that served to be a very large problem as the Kinect sensor must use USB 3.0.
So Matt's group has got the challenge of trying to not just work with the Kinect hardware and the software development kits that go along with that, but really trying to identify some set of human metrics, characteristics that would correspond to what represents a good interview versus what represents a bad interview. And although there is some science to it, a lot of it is just going to be, we want to take and digest all of this and come up with some set of numbers that we can capture. So if somebody's flopping around, or if they're picking their nose or doing things, being able to identify that you've got 23 distractive behaviors that we've identified. So it's not really around the technology at that point, it becomes more of a soft social science.
Probably the largest issue we faced, and still continue to face to this point, is taking from the demonstration that real-time feedback system of tracking mannerisms, taking those metrics and applying them to a representation, whether it be graphs or indications for the participants in their areas that they're struggling in rather. Taking those metrics and applying them to their learning and to changing their behaviors for the interview process to get replaced into the job world. Also, there was a small issue with voice recognition and speech so that the Kinect interface could serve as an automated interview provider. So when we looked into voice recognition and voice speaking capabilities, which the Microsoft Kinect sensor can easily do and accomplish, there were some issues. Now, those issues resided in the libraries of the code that we had access to and availability to use. With the Kinect sensor, you can select between Windows libraries and a set of Kinect Studio libraries. The Kinect Studio libraries carry a whole schema of great things and tools for developers to use in speech fields for things like interviews. Now, the Windows libraries serves a greater sense of functionality and integration with other devices. So in selecting those Windows voice libraries, as a result, we lost a lot of that special functionality that we would have access to in the Kinect libraries. So that left us with choosing third-party libraries from different sources. Now, that was all well and good and can be done and applied to the project and have moderate amount of success. The only issue is when we go to update the Windows systems, it affects those third-party libraries and may not serve that functionality for its initial purpose or intended purpose. So it would kind of just cause a lot of bugs, and we really didn't want to spend the time to try and debug as opposed to just forge forward with the things that we knew we could accomplish. The overall largest issue we had with the InterKinect system was with frame recording and frame rate capture. Now, the way it operates is the Kinect sensor scans multiple frames of the person sitting in front of it, whether that be an interviewee, a random bystander like myself, or any viewer, really. It captures those frames very rapidly and is able to display in real time the mannerisms. So that was kind of our way of telling the interviewee in our scenario, in our project case for Institute for Career Development, where the participants were struggling. Now, the issue with that is we have a lot of problems maybe quantifying that and keeping that data stored over a period of time in memory to then be analyzed, displayed, and fed back to the participant at the end of that interview. So that's where we're really struggling and trying to make better.